Okay, thanks for tolerating that. Little Madonna, throwback to I think that was the 80s. Well, welcome to CSC323 Programming Languages. We're going to be talking about expressions today. And the way we're going to do this is, I want to back up for a second and think about how you could describe an expression. So what we'd like to do is we'd like to describe the syntax for an expression. Now, most of you took compilers with Ralph, and so you know there's a few ways that you can do that. One really straightforward way of doing that is using something called the Bacchus Noir form, or BNF. So the basic idea behind the form is you have a symbol and you want to describe the syntax for that symbol. And so the way you might do that is you'd say, well, a symbol can be either A1 or some A2 or some A3 and so on. And then for A1, you'd say, well, A1 can actually be A11 or A12 or A13, etc. So what this allows you to do is define a symbol in terms of other symbols, and then those other symbols can then be defined in terms of other symbols, and you can actually have recursive definitions if you want. So it's just a super squeaky clean, simple, and fast way of describing the syntax for an expression. So I want to do a few examples, and in these examples what I want to do is I want to give you a BNF description, and then I want you to try to figure out what are some examples based on that BNF description for syntax. Okay, so let's do the first one. Example 1. All right, ID is equal to A or B or A ID or B ID. All right, and so my question is, can you give me 3 examples using this BNF description of expressions that involve A or B? Now, what I'd like you to do is hit that pause button for a second, come up with a couple descriptions on your own on a piece of paper, and then hit play, and let's see, compare your answers to my answers. All right, so hit that pause button. And we're back. Okay, so here are a couple of examples that are possible. So just A by itself would be fine. A, B, that would be okay. What about this? B, B, is that okay? And what about this? B, 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 is that okay? Well, the answer to this one is, yeah, that's fine. Let's see, to get BB, we would go to BID first. So that would be BID. And then, secondly, we just go to B. And that would give us, for the second ID, we'd resolve that by just going to B. How about BB? Well, we go to BID first. Then we'd go to BID again. So this ID would resolve into BID. And then we take that last ID and convert it just to B. All right? All right, so that's example one. So that's pretty straightforward. Let's try something a little trickier. And I think the idea here is I want to do two parts with this example. So part one is I want you to see if you can come up with a few examples based on this BNF. And then part two is like, can you tell me what the general pattern of this is? In other words, instead of saying, giving me examples, after coming up with a few examples, can you tell me what the syntax is describing in sort of 100,000 foot view terms, in the big picture? All right, so here we go. Start. Start is equal to ID equals EXPR, and then ID can be equal to A or B or C, and then expression, EXPR, can be equal to ID plus EXPR, or ID times EXPR, or EXPR, or ID. Okay? Now, what I want you to do is take a look at this BNF description, and then I would like you to tell me what, if we start at start, that's like the first place you begin as you describe this syntax. Can you give me a couple of valid BNF examples using this? All right, so hit that pause button, and then let's see if we can come up with some valid BNF examples. All right, go ahead, hit the pause button. Did you hit it? Okay, I'm going to do a little bit of magic here, just to shrink that down so that I have some space to operate and still look at these expressions. All right, so a couple of examples. How about this? A equals B. That could work, right? So we start with ID equals expression, and then ID gets resolved to A. The equals is still there, and the expression B, the expression gets converted to ID, and then that ID gets converted to B. So A equals B. That's totally valid. How about another one? A equals B times C. And how about another one? A equals B times A plus C. All right. So those are all valid. You might be wondering, if you're feeling a little weird about how these BNF descriptions get converted into these expressions that are over here, the syntax is over here. Let's take this one as an example. All right. So how do we begin with this? Well, we begin with start. And start says you have ID equals expression. So that's how we start. All right, well, this ID can be A, B, or C. So we're going to make this ID be A. So we're going to have A equals expression. Now, the expression can be any one of the following: ID plus expression, ID times expression, etc. Oops, I forgot a little paren there. And so I'm going to say that this expression then becomes A equals ID times expression. All right, and then this ID, I'm going to make that ID B. So that means that A is equal to B times expression. Now, I'm going to convert that further and say that this expression now becomes that particular value to the right of the definition expression, that syntax. So that's going to be A equals B times paren expression. That is going to become A equals B times, whoops, A equals B times ID plus expression, which then becomes A equals B times, I'm going to convert that ID to A plus, and then I'm just going to convert that expression to ID. And finally, we get A equals B times A plus C. Whew. A lot of work there, but we finally got through it. Okay, let's see. What is this describing? All right, so we have these three examples, but what are we describing here in this example? And basically, what we're describing is a simple assignment using basic plus, multiply, and parens. So simple assignment operation. Okay. All right, let's do one more. All right, so here is start is equal to minus number or number. Right, and then number translates into digits or digits, period, digits. And then digits gets converted into digit or digit, oops, let me move that there, or digit, digits. And then finally, digit is 0, 1, 2, 3, and we just keep doing that all the way up to 8, 9. You would specify all the digits here. You wouldn't put dot dot, but I'm just saving us a little bit of time. Okay, so that's the expression. Can you come up with a few valid examples of this? Sorry, that's the BNF description of the syntax. So can you come up with a few valid examples? All right, hit that pause button, try it, and then come back. Okay, so here's a couple of examples. 3. We'll just write these down as answers. 3. 3.14159. 1, 2, 3, 4, period, 4, 3, 2, 1. So those are all valid examples. So if you wanted to see how you would get to 3.14, let's take a look at that, what the process is, just to get to 3.14. We do start which transitions to number, which transitions to digit, digits, period, digits, which transitions to digit, period, digits, which transitions to 3, period, digits, which transitions to 3, period, digit. This takes a while. You could probably fast forward to get to the end, which becomes 3.1 digits, which then becomes 3.1 digit, which becomes 3.14. Whew, ta-da! Now, of course, for humans, doing this kind of translation from BNF into a specific example of syntax is quite tedious, but for a computer, it's not hard to do this at all. The thing that's so great about BNF, though, is it concisely describes the syntax of many languages, and so that makes it really, really easy. If you're asked to describe the syntax for something, for example, in a couple of the homework problems, I've been asking you to describe the syntax, for example, for variables in Fortran or variables in Perl, you could use BNF for sure to do that description, and you'd be right on the money. It would be hard to argue with it. It's very quantitative as opposed to sort of a qualitative description. Okay? Awesome.